Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about block diagram reduction rules and definition of basic elements of block diagram. This is linear control systems, lecture series on linear control systems and lecture number 23. So our topics, block diagram reduction rules and overview. What is the overview? First point, block diagram reduction techniques. And rules number 1, block diagram reduction for open loop systems. Rules number 2, cascade connection of blocks. Rules number 3, parallel connection of blocks. And rules number 4, shifting of a summing point after a block. Rules number 5, shifting of a summing point before a block. Rules number 6, shifting a takeoff point after a block. And rules number 7, shifting a takeoff point before a block. Rules number 8, shifting a summing point before a summing block. And rules number 9, shifting a takeoff point after a summing block. And rules number 10, rearrangement of summing point. So this is our overview. And rules number 1, rules number 2, rules number 3 already discussed in lecture 22. So our next rules number 3, 4, 5, 6, 7, 8, 9, 10. First point, block diagram reduction technique. And rules number 4, shifting of a summing point after a block. Shifting of a summing point after a block. This is reference input R of S. And this reference input forward direction, that's why this is always positive. And this is the summing point. We know that summing point 2 types, with cross and without cross. This is the with cross summing point. And another input X of S, this is also positives. So this is the output, and this output RS plus X of S. RS plus X of S. So G1S planned gain or system gain, planned gain or system gain, and the overall output C of S, overall output C of S. This is the figure 1. Our rules, shifting of a summing point after a block. This is the block for plant or for systems. And this is the summing point. And this summing point, before summing point, our target, a summing point after a block. Position this to position this. If this position 1 and this is the 2 position, so shifting this summing point after this block. Then what is the target? Shifting of summing point from position 1. This is the position 1. This is also before block, G1S block and the before block. And our target, this is the position 2 after block. This is the after block. So shifting of summing point from position 1 to position 2. And in this case, the output C of S equals to what? C of S equals to RS plus X of S whole into G1S, because this signal RS plus X of S and this is the G1S, so RS plus X of S whole into G1S. After shifting the summing point from position 1, that means before block 2, after block or position 2 as shown in figure 2. So what is the figure 2? This is the figure 2. RS equals to reference input, and this is the position 1. This is the position 1, and this is the block gain G of S or G1S, and this is the summing point plus direction, and this is the C of S, output C of S. Our target in this C of S equivalent to what? C of S equivalent to RS plus X of S whole into Z of S. So this is our target. C of S equals to, this is the output signal. Then X of S, another input, this is the X of S, and multiplied with gain G of S, and this is also positive. So this is the figure B. In this case, the output C of S equals to what? RS plus GS, because this signal R of S whole into G of S. And in this case, this is the G of S into X of S. So C of S equals to what? C of S equals to this signal plus these signals. This signal plus these signals. Then RS into GS plus GS into XS, or RS plus G of X of S whole into G of S. When the summing point is shifted to the position 1 to position 2 of the block, then the signal X of S must be multiplied by G of S. So when signal shifted in this position to in this position, then the signal X of S, this is the X of S, must be multiplied by G of S to keep the same output, or RS plus X of S whole into GS out of output. Then shifting of a summing point before a block. Before a block, this is reference input again R of S, and this is the R of S system gain or planned gain, and this is the plus or summing point. This is also called comparator, and forward direction, this forward signal always positive. Another input X of S, this is also positive input, and overall output C of S. What is the output? Output equals to RS, this signal R of S into Z of S. So right here, R of S into Z of S plus X of S plus X of S. This is the output or controlled output. So what is the target? Shifting of summing point from position 2. From position 2, this is the position 2 after block. This is the after block, and 2 position 1. This is the position 1 before block. This is our target, position 2 to position 1. In this case, the output C of S equals to RS plus GS plus X of S. RS plus GS plus X of S. After shifting the summing point from position 2, that means position 2 after block 2, position 1 before block, as shown in figure B. So what is the figure B? Reference input R of S, and this is the position 1 and summing point and G of S. The overall or controlled output C of S, and this is the position 2, this is the position 1. Then X of S, this input, and this input multiplied by 1 by Z of S. Because why 1 by Z, multiplying by 1 by Z of S? And this is also positive, because in this case RS plus XS by ZS. This is the XS by ZS signal, XS by ZS signal, and this is the RS signal. So CS equals to what? See, RS plus XS by ZS whole into this signal G of S. This signal G of S, or RS plus GS plus X of S. So figure 1 and figure 2, ultimate, the overall output is same. To shift the summing point to the left of the block G of S, divided the signal entering the summing block by G of S. Then shifting a takeoff point after a block. This is the RS or R of S reference input signal, G of S system gain or planned gain, C of S controlled output. And this is the node, or this is also called takeoff point, another branch R of S, because this is the R of S, this is the node, and this path 1 signal, and this path also R of S, and also CS equals to what? This signal R of S, and this is the G of S, so multiplying R of S into G of S. In this case, RS always constant and CS also constant. So our target, what is our target? Our target, this takeoff point 1 to 2 position, this is our target. So this is figure A. In figure A shows a system where the takeoff point is to be shifted from position 1 to position 2 after the block. The value of R of S and C of S should not change after shifting, and to keep R of S constant, divided the takeoff signals by G of S after moving the takeoff point, which is shown in figure B. So what is the B? This is R of S and takeoff point shifted position 1 to position 2. So this is the controlled output C of S equals to GS into RS, and this is the position 1, and this is the target point position 2, and this signal also R of S. So this is multiplied 1 by GS, then the output RS. Why? Because this is the output RS into G of S, and multiplying this into 1 by GS cancel, and this path output always R of S, R of S. So this is the GS into R of S signal. So this is the figure B, and this signal GS into R of S, output C of S. Shifting a takeoff point after a block. Shifting a takeoff point after a block. So R of S equals to reference input, G of S equals to planned gain or system gain, and C of S equals to output and or controlled output, and this controlled output equivalent to GS into R of S. Reference input RS and system gain G of S. Then this is the takeoff point and position 1 position. And what is the output? Output SS feedback. This is the feedback gain, and output equals to RS multiplied by H of S. So RS into H of S. And this is the position 2, our target position 1 to position 2, shifting a takeoff point. This takeoff point shifting from position 1 to position 2. And this is the figure B. R of S reference input, G of S planned gain, and overall output C of S. This is constant always, G of S into R of S. Then this is position 1, this is position 2. When this takeoff point shifted at position 2, in this case, H of S divided by G of S, because why? Multiplying 1 by G of S, because this output R of S into H of S, this is also R of S into H of S, because this path, this signal RS into G of S, and this signal multiplying by SS by G of S. G of S cancel, R of S into H of S. This is the output, R of S into H of S. This is figure B. Then shifting or takeoff point before a block. This is the R of S, and the gain, system gain G of S, system control output C of S, and this signal equivalent to RS into G of S. This is the takeoff point, and this takeoff point equals to RS into G of S, because this path signal actually R of S into G of S. Our target position 2 to position 1. Shifting this takeoff point position 2 to position 1. This is figure 1, figure A. And after shifting RS, G of S, and the our controlled output C of S equivalent to G of S into R of S. This is the takeoff point, and position 1, this is the position 2, and in this case multiplying by CS, because this signal R of S, this is the R of S signal, and this is the also R of S, and our target GS into R of S. So RS multiplying by G of S, and this is the satisfied. This is satisfied. This is figure B. When the takeoff point is shifted to the position 2 to position 1 before the block as shown in figure, the dotted line in figure A. Then shifting a takeoff point before a block. Again, just multiplying H of S, and we get this is the R of S, this is G of S, and multiplying also H of S. So GS into R of S into H of S, because this signal G of S into R of S. This signal G of S into R of S. So this is multiplying by H of S, and the output X of S equals to G of S R of S into H of S. Then this is also CS into H of S. CS equals to, because GS into R of S. CS equals to GS into R of S. This is equivalent to C of S. Then after shifting, this is the GS into RS. This is a position 1 takeoff point, and the path GS into SS, because XS equals to what? XS equals to GS into SS whole into R of S. This is our target, GS into RS into H of S. This is equivalent to CS into H of S. So this is the figure B, shifting of takeoff point before a block. This is the before block shifting of takeoff point, this position to this position. Then to shift a takeoff point behind a block, add a block having transfer function same as that of the block beyond which takeoff point is to be shifted in case cascade with all the blocks at the takeoff point. Then shifting of takeoff point before a summing point. This is R of S. This is the summing point or comparator. Another input Y of S, and this is the takeoff point, and this is the summing point. And this summing point output, this takeoff point, this path output equals to X of S. And this X of S equals to what? This X of S equals to actually this signal RS and this signal plus minus Y of S. This is the output X of S. This is our target after shifting of this point to this point. So this is a position 1 and this is position 2. Our target, this arrow direction. And this is figure A. Figure A shows the initial situation of the takeoff point. And this case, XS equals to RS. This is the reference input RS plus minus Y of S. And RS equals to, and this is the summing point plus minus, and Y of S equals to input. And C of S equals to what? C of S equals to ultimate. This is the takeoff point. And this takeoff point, suppose this takeoff point output equals to Z of S. Z of S. What is the Z of S? Value of Z of S. Because in this case, Z of S equals to RS, because just this is the path RS. But actual calculation from figure B, it can be written Z of S equals to R of S. Therefore, Z of S not equals to X of S. Then equivalent circuit R of S plus, this is the summing point or comparator, and this is the controlled output C of S. Another input Y of S. then one summing point added, and this is the output Z1S. What is the Z1S value? What is the Z1S or ZS value? This is the position 1 to position 2 from figure B. It can be written Z of S equals to R of S. Therefore, this is the Z1S equals ZS equals to R of S. Therefore, ZS not equals to X of S. From figure C, the signal Y of S is added to Z of S by summing point with the same sign. In this case, Z1S equals to RS plus minus Y of S, because this path RS, this is positive, and this path plus minus Y of S. So Z1S equals to RS plus minus Y of S. And Z1S equals to RS plus minus Y of S. Then XS equals to Z1S. So figure C is equivalent to the figure A. Then shifting of a takeoff point after a summing point. This is the reference input R of S, and this is the comparator summing point, and another input plus minus Y of S. The output C of S equals to RS plus minus Y of S, and another output from this branch X of S. And this is the position 2, this is position 1, and R of S reference input plus always, and this is the Y of S, position 1 position this is. So this is the C of S, and plus Z of S. And what is the Z of S? Z of S equals to what? Z of S equals to this output plus this output. This is the R of S plus minus or minus plus Y of S, minus plus Y of S. And from the figure B, Z of S equals to RS plus minus Y of S, minus plus Y of S, only R of S. So figure A and figure B are equivalent. Rules number 10, rearrangement of the summing point. Any two consecutive points may be interchanged as shown in figure A and B. Suppose this is R1S. This is the R1S, positive sign. Another input R2S. This is negative. So this output R1S minus R2S. And another summing point input R3S. So what is the output? CS equals to R1S minus R2S plus R3S. So equivalent circuit. R1S reference input, summing point, this is forward path always positive, and this input suppose R3S, and this is sign positive, and another input summing point or comparator with cross, this is input R2S, then C of S equals to what? Any two summing points are directly connected to each other. That is, there is no intermediate block between two summing point, may be interchanged. Then negative feedback closed loop control systems, already discussed in lecture number 18, 19. This is reference input, this is the forward path, this is comparator, ES equals to actuating signal, GS equals to planned gain, and this is the controlled output, and HS equals to feedback gain, and this is B of S, feedback signal. So hence the above feedback system can be reduced to a signal block shown in figure below. R of S reference input, and already proved this is the GS by 1 plus GS by 1 plus G of S into H of S. This is the output C of S. So CS by RS equals to GS by 1 plus GS into SS. This is the definition of transfer function, and all initial conditions 0. And denominator terms 1 plus G of S SS equals to 0 is called the characteristics equation. It gives the system stability. It gives the systems stability. In positive feedback system, similarly, same block, just what is the output? CS by RS equals to GS minus GS into SS, because in this case, this is the positive feedback. So in this case, this is the negative sign. And the single block is as R of S, GS by 1 minus GS SS, and the output control output C of S. Then positive negative feedback similar, minus plus just C of S by R of S equivalent to G of S by 1 minus plus G of S SS. For positive, this is negative. For negative, this is positive. And the single block diagram is as RS reference input, CS controlled output, and the gain system gain GS by 1 minus plus GS into H of S. Then unity positive, this is the unity feedback path. This is the unity feedback path, because this no gain. In this case, no gain. So CS by RS equals to what? CS by RS equals to GS by 1 minus plus GS into H of S. Here, in this case, SS equals to 1. And for plus, this is negative. For minus, this is positive. This is positive. And the single block is as, this is a reference input, and GS by 1 minus plus G of S, and the output equals to C of S. This is the unity positive feedback control systems definition, CS by RS. So thank you.